Metal access defect. What is metal access defect? We will be study about metal access defect today. Okay. Then metal access defect. In metal access defect, positive ions are increases. This is of two types also. Okay. In metal access defect, in metal access defect, in metal access defects, positive ions are in defects. Positive ions are in excess. Okay, these are two types. A is metal access defect, and B, metal deficiency defect. Metal deficiency defect. Okay. Then metal access defect. First is metal access defect. Metal access defect. In metal access defect, positive ions are in excess. There are two types of metal access defect. First is anion vacancies. And second is extra cation in inertial sites. Extra cation in interstitial sites. Okay. First one, anion vacancies. What is anion vacancies? Okay, we will be study about anion vacancies. Okay. Anion vacancies. What is anion vacancies? Okay. A negative ion may be absent from its lattice side. Lattice sides. Okay. A negative ions. Or negative ions. Or negative ions may be absent. May be absent. May be absent from its lattice site, from its lattice site, lattice sites, from its lattice sites, leaving a hole which is occupied by, leaving a hole which is occupied by, an electron to maintain the electrical balance. An electron which is occupied by an electron to maintain an electron to maintain the electrical balance. Maintain the electrical balance. Okay. This is shown in this figure. You can show this is the electron. Okay. And in this type of crystal defect, in this type of crystal defect, there is an excess of positive ion. There is an excess of positive ion. There is excess on positive ion, cation or metal ion. This is known as cation or metal ion. Cation or metal ion. But the crystal as whole is neutral. But the crystal as a whole is neutral. Okay. This type of defect is observed in those crystals. This type of defect is observed in those crystals which are likely to form Schottky defects. Okay. For example, when sodium chloride is treated with sodium vapor. For example, when sodium chloride is treated with a sodium vapor, a low non-stoichiometric form of sodium chloride is obtained in which sodium positive ions are in excess. Okay. The extra positive charge due to extra metal ions is balanced by the negatively charged free electrons present in the lattice. Okay. Next is the extra cations in interstitial site. Second, extra cations in interstitial site. Okay. Extra cation in interstitial interstitial sites. Industrial sites. Okay. Extra cations in industrial sites. Okay. Metal. This is metal excess defect. Metal excess. Metal excess defect. Defect. And this is a metal excess defect due to industrial cations. This is an ion industrial cation. Okay, cation. Okay. Extra cation industrial sites. Metal excess defect also occurs when an extra positive ion occupied. Extra positive ion occupies an industrial position in the crystal lattice. Electrical neutrality is maintained by the inclusion of an industrial electron. This has been used as this figure, and this type of metal excess defect is somewhat similar to Frankel defect, but here there is no hole and have industrial electrons. This type of defect is more common than anion vacancies. It is found in crystals which show Frankel defect. Okay. Metal excess defect. Metal excess defect. Metal excess defects also occur when or extra positive ion occupied an industrial position occupies an industrial position interstitial position in the crystal. Lattice electrical neutrality is maintained by the inclusion of an interstitial electron okay, electron. Extra cation interstitial sites. Metal excess defect also occur when an extra positive ion occupies an interstitial position in the crystal. Okay, the lattice electrical neutrality is maintained by the inclusion of an interstitial electrons. This type of metal excess defect is somewhat similar to a Frankel defect. This type of metal excess defect is somewhat similar to Frankel defect. But here there is no hole. But here there is no hole. And have interstitial electrons This type of defect is more common than anion vacancies. This type of defect is more common than anion vacancies. It is found in crystal which show Frankel defect. For example, ZNO, CDO, Fe2O3, etc. ZNO is white when cold but yellow when hot due to this type of defect. Zinc oxide is white. Zinc oxide is white. Okay, zinc oxide is white when cold, but yellow when hot due to this type of defect. The color is due to non-stoichiometry. When zinc oxide is heated, O double negative and from lattice sites is conserved to 1/2O2. Okay, 1 minute. When zinc oxide is heated, then O negative from lattice sides is conserved to 1 by 2 O2. How to? O2 negative is 1 by 2 O2 plus 2 is negative ions. Okay? Oxygen escapes. Oxygen escapes and electrons remain in the lattice. Due to heat, electron moves from one lattice side to another lattice side. Okay? Due to heat, electrons moves from one lattice side to another lattice sides, giving rise to color. Giving rise to color. And cooling you didn't know, atmospheric O2 is conserved, and uncooling zinc oxide, atmospheric oxygen O2 is conserved to oxide and sites in the lattice side. Okay? And seeds the lattice sites. Okay? For sodium chloride. Okay? And the next is metal deficiency defect. What is metal deficiency defect? Metal deficiency defect. What is metal deficiency defect? Okay?